Hello, everyone. Thank you for joining us today. We are presenting the CTO point of view, Enterprise Networks Part 2. We have the security for IoT and Cloud. Today's presenters are Khalid Raza with our Viptela organization, and as well, we have Danny Johnson joining from Verizon. Khalid is our distinguished engineer from Cisco, as well our founder here. And then Danny Johnson is the Director of Product Marketing Network Services as well, from the Enterprise Solutions. The two of them are going to have an active conversation around our security for IoT and the cloud discussion. I'll let Khalid go ahead and take it from there.
Good morning, everyone. Welcome back to the part 2 of the POV of CTO, and I'm very grateful for Danny from Verizon to join this session, because Verizon has been a great partner. They are partnered with one of the largest deployments that we have. So let's pick this back up from the previous discussion we had. I mentioned about software-defined networking is about very clear abstractions. So when we looked at Viptela from security angle, a few things are very, very critical for security. From security perspective, confidentiality is very important. Integrity is very important. But anything without authentication has no value. So authentication, integrity, confidentiality, and with the advent of cloud, one thing, and very large connected site-to-site connectivity, scalability has become as equally important in these type of environments, especially if you're saying, I'm going to augment your MPLS VPN with any other kind of transport. So in the days of, especially with infrastructure as a service, platform as a service, and with the rise of IoT, as I mentioned, scale is important, and then you have to embed a very large-scale layer 3 network, which has to be secure. Especially with the amount of virtualization that happened in the data center, the problem in wide area is much bigger than when you, as compared to data center, because you're coming from an unknown site, unauthenticated devices have to be properly authenticated and brought into your network. So it's a much bigger problem, security point of view, arbitrary meshes, arbitrary point connectivity. So from that perspective, the device that shows up in the infrastructure as a service or any pass point, you as an IT security guys, you have to make sure that your network is also following all the compliance, and hence your security footprint, your network transport security footprint becomes a much larger element than previously. So moving on, when we looked at this problem, we looked at it and said, so security, IPSec was traditionally network security protocol that was used. And it was pretty much structured for a point-to-point connectivity. People had tried to solve this problem through GDI, but GDI obviously had some interesting challenges. Number one, it was designed for a trusted third-party network like MPLS. So you had a group key, all the members of that peering sessions had a common group key. So when you move this concept of the internet, the single group key can compromise your entire network. The second issue was that your IPSec SAs were not synced with your routing. So you were relying on the underlying routing. So any out-of-sync models that your routing is working and your you don't have your SA, or you have the SA and not the routing, because those are two independent control sessions, you can get out-of-sync problems. So what we looked at is how can we make this as a massively scalable problem? And again, I've noticed a lot of people coming in talking about SDN, they're not taking a very crystal clear view on the network security angle. How do you build these large, huge meshes? So when we looked at IPSec, if you look at IPSec was traditionally designed for a very predictable hub and spoke type topology, because your data was residing in your data center, all your access was in the data center, and even your internet access were in a lot of cases from data center. Even the infrastructure as a service was considered part of extension of your data center. So again, the problem people had always tromboning from data center is I might have an infrastructure as a service point right next to me, but I'm tromboning through East Coast just to go to that infrastructure as a service point. So the change was that any element has to become part of your infrastructure, not a defined exit point. So from that perspective, IPSec, when you go to an N mesh and you create a full mesh problem in control plane, we, the large-scale routing guys, had suffered from it in the early 90s. In the early 90s, I clearly remember we had a very large service provider who had a meltdown because of the full BGP mesh. Hence, Route Reflector was invented. So again, you had a client that is connecting to a server, and that server is reflecting. So from that perspective, this was obvious to us that we needed to solve an O to the power n square complexity and turned it into O to the power n. So when we looked at this problems, how can we do efficient key distribution? Security is about authentication and efficient key distribution. So if you did true separation, if you look at the control plane mesh is a very complex problem from control plane perspective. You have n square mesh, every peer has to be brought up, and a single outage from a peer, it has to disrupt all other peers. Take that to a true SDN. In true SDN case, a device coming into the system from control plane perspective. Now this is very important because if you did proper control and data plane separation, from control plane perspective, any data plane element coming into my network just has to connect to few controllers. And then it's not a control plane scale problem. It is some kind of a data plane liveliness detection problem, which is always a very lightweight protocol. You don't have that heaviness of a control plane. So I can build any arbitrary mesh or any type of mesh that business requires. And this whole idea of on-demand connectivity is, again, you're building a second control plane just because you haven't solved the proper IPSec data control and data plane separation. So from talking to our customers, it was very obvious. The next generation network required ubiquitous connectivity regardless of the type of transport. MPLS was very, very attractive, and they took MPLS to the next level, because the enterprise gave away the complexity, gave away the control plane to the carrier, but got a full mesh, whatever mesh they needed, ubiquitous data plane. Now, if I go take internet or any LTE connection, expectation from the enterprise is, great, you're giving me a higher bandwidth connection. I want the same ubiquitous connectivity, because if you look at the growth in my network, video is one of the fastest growing site-to-site connectivity. So if I want to do video, I'm increasing my bandwidth over the internet as an alternate circuit. I need to have the exact same connectivity model that I had in the MPLS. The second piece of it was segmentation. The partner access is becoming a very critical piece of your network, and it's going to continue to grow. So if that continues to grow, I might be sending data to a third-party system for video surveillance, building management, digital signage, and in future, a lot of this IoT data, again, goes to a partner which is doing large-scale analytics for me. So if you continue to keep on putting point-to-point circuits, you will run into problems, scale problems. So when we at Viptela looked at this and says, if we solve efficient key distribution, tie key to the actual destination, which is transmitting data, then you can solve this massively scalable key distribution problem. Along the way, we looked at so many different variables. When you're in an MPLS environment, you know the destination prefixes that you'll be connecting into. Turn that into an internet connectivity. What happens in the internet connectivity, IPv1, IPv2 solves the NAT hole problems. So you can connect site to site around for NATing. So you open up port 4500 for NAT connectivity. But what happens is when you're doing these site-to-site hole poking, every data plane element that connects into your network is a server. So you will have thousands and hundreds, let's say hundreds and hundreds of connections, which are server to server. So you have to understand and put your security in place properly. Now, can change that to a true SDN model. One of the elegance of SDN model is the data plane device is a client, and that connects to a controller, which is the server. So when client opens up the hole, it is connecting as if it's connecting to any other server that traditionally a user connects to. So you have a return path. It's a properly opened up net hole. So one of the things that we advise our customers in Viptela is we don't care where your controller is sitting. In fact, we promote your controllers should be sitting behind a net. And we expect all the remote ends to be sitting behind the net, because then with the intelligence system, you get that information across controllers, and you can easily open site to site using some predefined ports that have been opened from a client, and now site-to-site communication can happen across any kind of net. And I'll touch this a little bit more at a later point. So with that, I have Danny with me, as I mentioned. Danny team is responsible for deploying one of the largest SD-WAN networks Viptela has, over 6,000 sites. And I would love for Danny to give his input on how the deployment went, and when they are saying that, okay, to the customer, you can do away with the second MPLS, get a complete service from Verizon. Verizon provided MPLS, broadband, and LTE. But the customer requirement was, okay, you have to duplicate the way MPLS working over any kind of transport. In worst case, the tertiary transport, which is LTE as well. So I want to get Danny's take on how was the deployment and what's his take on this new way of using the transports.
Yeah, thank you. Thank you, Khalid. And with this particular deployment, and we're finding this to be the case on really any large-scale deployment or even mid-sized deployment, it really starts with some of the customer challenges. So let me just kind of start there, because to understand the customer challenges and application needs really kind of wires to the ground the importance of some of the key areas that Khalid just talked about, which essentially are scale, security, compliance, and segmentation, which all are really met with this joint solution with Verizon and Viptela. But to start with the application, this particular use case with this particular customer, the customer really needed to accomplish a few things. One, they needed to open new branches not only on time, but also in a quicker fashion. They needed to increase the network stability and decrease the time to repair, and then also reduce network complexity. I mean, I think all of us can agree. We are in a paradigm shift in how networks are actually being orchestrated today. Hybrid options are becoming more prevalent because of the introduction of just the price compression on price per bandwidth. So public bandwidth type of network connectivity options, whether it be public internet or broadband, are really coming to bear. And then the increase of bandwidth really to drive new applications to the bandwidth to all their branches. However, more bandwidth doesn't necessarily equate to better quality. Now, some of the challenges really that existed with this particular client were they had an aging bed of CPE within their environment. They did have insufficient bandwidth to improve their customer experience, and this is very critical. They needed the appropriate level of application availability to help reduce the impact from extended outages to their client base, because this particular client is really moving to very much content-rich, integrated application services to their client base. All right. So not only are they deploying new applications out to their client base, but they're also wanting to converge on video and voice-based applications as well. All right. So essentially, what did this solution offer? It offered all the components around scale. All right, so let me touch on that for a minute. Being able to scale across a hybrid network environment, that is very critical. Being able to deploy new retail locations faster than they ever had before. However, in this particular segment, it goes without saying, security is paramount, both security and compliance. So what Khalid is really talking about in terms of the implementation of the security layer within a control plane abstraction is critical because that allows this particular client to scale. Look, you're looking at more than 1,200 plus sites globally, as well as at the same time meeting security and compliance requirements. And then lastly, you see here, I mean, there are our clients are working with other partners as well, and being able to provide not only an agile infrastructure but also the security implementation to ensure that there's end-to-end visibility into their applications. In this particular case, being hosted by third-party providers, we were able to jointly provide end-to-end visibility into their application domain from mobile to cloud, leveraging quality of service, enabling the applications to have the appropriate level of treatment within a very and highly secure environment. So this is a very compelling solution, and the strength, of Verizon and Viptela really was able to kind of nail the customer challenges and really help this particular client in all of their strategic goals.
Thank you, Danny. So Danny had mentioned the customer that we had jointly went into, that they were trying to bring up their sites in very quick fashion, and any location they would come up, they wanted to get any type of circuit available and bring that secure, ubiquitous connectivity. But if you look at in this concept, we're literally making IP as the transport. As long as sites have an IP connectivity, even if one site is on internet, the other site is on MPLS, as long as there is an IP connection between them, they will be able to build that ubiquitous data plane. So from our perspective, as Danny had mentioned, you cannot continue to send truck rolls. So for any site you bring up, zero-touch provisioning was a very key piece of Viptela's solution. It's zero-touch provision. You can connect to the controller, and before you connect to the controller, there is an element that authenticates you. That's the only element that is required to have a public IP address. So we authenticate through certificates, and then we let you establish a DTLS connection with the controller. So during this process, the system has intelligence to figure out the type of NAT that is there, because Viptela can actually form connection between site to site. But remember, the controller is at a central location. Sites require a ubiquitous data connectivity. So how do you connect those site to site across any kind of NAT? In fact, one of the things that we are very proud of is Viptela can connect sites even across symmetric NATs. And interestingly, when you're connecting sites through NATing, you cannot integrity protect the data. Again, if you do solve these problems elegantly, we actually can integrity protect even if the IP addresses along the NAT changes. In fact, this is an interesting security tool for us, that man in the middle doesn't know what elements have been integrity protected. So even if the addresses are changed, doesn't matter to us. The true integrity protection happens between the two data plane points, and intermediate points have no visibility of that integrity protection, even through NATs. So for us, it was very, very important to build the capability to build ubiquitous network across all data planes. As I had mentioned, one is MPLS, the other is IP. We didn't care. So from the perspective of large meshes, if you look at the scale problem, again, I had mentioned, say I have 1,250 sites. Now, any device failure, say one site goes away, it has to, during the reboot, it has to reconnect with about 1,250 sites from control plane perspective. So you have to figure out how you throttle the system, whether it's a true connectivity or a DOS attack. Compare that to a proper SDN connection. That is why Viptela never advises its customers, okay, you want full mesh, you want mesh connectivity, please do it on demand. We say, we do not dictate how your network should build. The networks were always based on topology. Tomorrow's elegant networks have to be built on policies. So you as the customer decide your policy. We don't decide your policy. If you have that requirement, in fact, one of the most interesting things, we were working with a healthcare provider. Now, healthcare providers have very, very stringent requirements of latency, both healthcare and manufacturing. So a lot of architectures that gear towards pure retail, it's a slightly different requirement. But those requirements, if you start to talk to retail guys, they'll say also changing because for Skype for Business, I want site-to-site video. So that healthcare provider clearly told us, I have a full mesh MPLS as my primary. During migration, think about it, even during migration, site to site, I want ubiquitous connectivity. if you've architected it properly, that should not be a problem. So half of the sites that were not migrated from MPLS were going through MPLS. The other half that had migrated to Viptela were using primary as Viptela and secondary as MPLS. So we did not disrupt that full mesh connection, because the requirement, they clearly told us, hey guys, we have a 19 millisecond latency requirement from these sites, which our imaging application requires. So you can't backhaul it to a data center point, which might introduce another 30 milliseconds of latency. So for us, that was the key. And again, imagine 1,200 sites rebooting. You will have issue rebuilding your control plane. Believe me, anybody who's played with big networks, have worked on big networks, have seen those outages, have understood how these scaling happens, how these control planes start to get out of control when you have these very large meshes. Or even on demand, you can't tell a customer that, okay, your MPLS is full mesh, take the second circuit out and put my second on-demand path. Imagine healthcare. I have a 19 millisecond requirement. I have site-to-site connectivity. Should I wait while you're building your IPSec tunnel? That does not scale. So these are questions that you have to ask, that if somebody has done proper key management, have understood scale well, will always be able to build this any arbitrary points. So requirements by the customer. So from that perspective, we can scale any type of IPSec mesh over any kind of transport without requiring or without asking you to abide by my rules. We don't tell you rules, you tell us the rules, that this is what I want in the network. So the next question that we looked at is how elegant our DDoS mitigation should be, because some of these edge routers are exposed to the internet. So we have this element I had mentioned, a VBond, which is the first element which authenticates these devices. So now we have, once we establish our connections to the controller, we only allow known flows. So only known flows are allowed to go to the control plane. So nothing more. And in case of a control plane on an edge device, you might have 4, 5 control plane connections. And on top of it, you can put an implicit ACL. So only these 5, 6 guys I know are allowed to connect to my control plane. So anybody who tries to attack, on top of it, we throttle those connections. So to the CPU, we know that we have, we throttle how many packets can go to the CPU. So from control plane perspective, we know the known flows, we can put an implicit ACL, any unknown flow does not connect. So this data plane element, which has only few connections to the control plane, can seriously scale. Now, coming to the data plane is on the fast path. So you can, that's a simpler problem to solve. So again, as I mentioned, always keep that in mind, a full plane IPSec, full mesh IPSec control plane. And that's why most people realize that there is a flaw of a second control plane in IPSec with IKE they're introducing. They'll always recommend you, oh, don't build full mesh, just build based on demand. One of the reasons is, just imagine one site has 1,000 IPSec connection, IKE peers. At one time, you will not be able to differentiate whether it's a DOS attack or it's a reboot. So plus your control plane also has the view of the entire network. So if anything happens at any point in the network, you can take that element out. Even within a site, if there is an element that is misbehaving, you can service chain through a segmented path. So that was, for us, that was a very key part of it. The second piece of it is...
Hey, Khalid, could I just inject a question real quick on your last slide? So what if I'm interested in moving my control plane to an MPLS-only environment, as you just described here, in terms of the capabilities there? Is that feasible?
So that's a very interesting question, Danny. And we've had this discussion with your federal guys, and we've talked to other federal organizations. So having control plane on both isn't high availability thing. So that regardless of the type of circuit going down, it's perfectly fine that you build control plane on internet and also build a control plane on MPLS. As we moved into the federal space, this is one of the questions which a lot of federal guys really like the elegance of our solution. So you providing service that say, I just want to build my control plane on a private environment, could be MPLS in case of a lot of agencies, it's only over satellite. So that control plane over one infrastructure is only accessible to me, which I have a clear visibility, but the data plane I can build over the internet. So if you think about this, you're not sending a single packet, and you're showing up in a deployment at any location, any hostile environment. You're showing up at any hostile environment. You can get an internet circuit. You do not build a control plane on that, but you still be able to pass the data plane between those 2 points. From commercial point of view, the customers are completely comfortable building it over both. From federal, we've heard this very specifically. I should have the flexibility to build my control plane over any kind of transport. And again, that's the elegance of a proper SDN solution. So thanks for the question, Danny. So another thing that Viptela focuses is on deep packet inspection. So if you look at how we use these deep packet inspection, we have individually 3,000 flows. And we recognize those applications, we profile those applications, and then on top of it, if one of the things that we've heard from IT leaders, that their line of business says, hey, I want flexibility. My marketing team wants complete freedom to pick an application. Now, put that in the context of a financial environment. You have a compliance regulation, so you're saying, I'll permit these applications, just make sure that they're compliant by my system. So in that case, if I'm permitting the marketing team to have access to a certain application, I'll profile that. And I'll look into it and said, these are the applications which which were permitted, or any other element, say, investment banking. You're not allowed to use that application from a local exit while you're allowed to use it backhaul through a compliance point. So you should have the flexibility to identify application, to the control application, and if any of these applications does not match, which is out of profile, you should be able to drop those applications on per segment basis.
Hey, Khalid, quick question on this one as well. I mean, so Verizon has deployed, our virtual network services model, that service chains VNS or other applications within a virtual environment. Is this something that could also be deployed in a service chain architecture?
So absolutely, Danny. As I'd mentioned, the compliance point. So whoever is buying service from you can always put a compliance point, or Verizon can provide that compliance point. So I can put a service chain path. Some of these applications which are permitted can take a DIA, but certain applications will have to go through that compliance points inside of Verizon's network and say, if that's the application, hits the profile, it's within that segment, and it will always go through that service chain path. And rather than all applications being permitted, I can control which applications and which application goes through a Verizon offered or any compliance point. And in certain cases, some of our customers are using Zscaler to backhaul that to a Zscaler point. So, but that's all part of the architecture that was put together to be very dynamic, and what customer wants to do, how they want to profile, how they want to build their policies inside of the network. That became very essential for us. So let me just touch this briefly on the IoT side of it. So we've seen consistently from our customers, in fact, in financial space, they were actually building third-party networks to bring these different services they were trying to get into the network. They wanted their network to be completely separated. So our video surveillance, you had a smart building solution. So on top of it, you might have a PCI compliant site on the same network. If I'm a healthcare industry, I would require HIPAA segments. So each one of those segments are individual, and each one of them has their own independent topologies. So once I recognize the applications, once I profile the application, that application is required to use that segment only. No other application can use that segment, and each of these segments have their independent topologies. And just imagine, with digitization, your partners in a lot of cases would be coming from the internet or from the cloud to access the data that they are required to use. So if I'm your video surveillance provider, I'll come from an arbitrary point on the internet. So me being the network administrator should make sure that point coming into the network has only access to the application or the segment it's supposed to, and that other end of this element is, again, applying by my compliance and no other element should be able to connect to it. So I should have this capability to do whitelist topologies. If you're not following my whitelist topology, something is wrong. And I could pivot your path to the service chain path as on needed basis. So if you look at it, as Danny had also mentioned earlier, our customers are ultimately looking for improved application performance. From SaaS perspective, from infrastructure as a service perspective, from any cloud points to do a dev and test for PaaS, I need to have my compliance into the any element. I cannot continue to ask you to, based on your requirements, to follow my rules. You should tell us our rule that this is how I want my network, this many meshes I need. I'm putting a video in place. I'm putting a SaaS infrastructure in place. I'm putting a PaaS infrastructure in place. And anytime a new site comes in, it's additional to the data plane, not that heavy burden on the control plane. So for scalability purposes, for the true abstraction of data and control plane, there is some serious innovation what was needed rather than continuing on the traditional model of point-to-point IPSec, IKE-based control plane. And Viptela solution, one of the biggest thing has been driving our solution successfully in healthcare and retail and financial is A, compliance, B, I dictate how my system should work, and I have the access of the control plane which I need to build in a secure or fashion. And as we grow, I expect any arbitrary point, and I should be able to connect it with a very single orchestrated policy, and I'll make sure at the center the policy is compliant, then I'll let that application go. With that, I'll stop, and I'll open up for questions. Is there any question, Courtney?
So we do have one that came in here that says, in a case where separate control planes are dedicated for MPLS and Internet, is it possible to have both of them federate and exchange routing information for seamless experience?
So
my eyeballs are going.
So to answer that question, so one of the things I've mentioned is our control plane runs over both, and routing works seamlessly. We are large-scale routing guys. To a point, Viptela understands routing loops across multiple topologies. If one is MPLS, the other is Internet. We've taken care of so many things clearly that you will enable underlay, overlay seamlessly, and the routing loops won't happen. So from that perspective, the control plane is single over either type of transport. The question Danny was asking is, some of his federal customers have asked him, and some of our federal customers have asked us, is I don't want to put the control plane on purely on Internet. Most of our commercial customers are perfectly comfortable, so either it's MPLS or Internet, it's a single control plane. And that single control plane interacts with your traditional routing and interacts very cleanly with your underlay and overlay. Any more questions?
I see one coming in here, key server. So this one, it looks like it's directed toward Verizon. Danny there, how is your solution better than the key server model?
I can explain.
So yeah, go ahead, yep.
Yeah, so here's the issue with key server. Key server has two interesting problems. A, the key server and the routing can get out of sync. Key servers can have split brain problems. So key server detaches the location you're trying to protect from the encryption keys. So that's my take on it, and then I'll have Danny give his take on it.
Yeah, no, and I think Viptela's implementation is critical, all right? Because when you look at the abstraction of how Viptela's solution, is actually handling key exchanges, to be able to do this across a hybrid network environment becomes very, very complex, okay? And so I think being able to have a single control plane to manage that entire ecosystem becomes very, very relevant. And so I think at its basic root, that's the value behind not having the traditional way of key exchanges, where I'll give you another example. One may not suggest that we may need it for MPLS, but then when you introduce broadband and other public internet-based strategies, you may have a mix of them. But then when you enter SD-WAN, and the implementations for SD-WAN really are predicated also on encryption, this becomes a very pronounced and compelling value proposition for our clients. It simplifies the network for our clients and enables them to scale very rapidly.
Great. So yeah, we've got a few more questions streaming in here now. We're just past the 30-minute mark. So we have, what is your support for third-party DNS strategy for the edges?
So I think I earlier mentioned in my previous webinar, we have a couple of hardware and we have software. So if you take a Viptela software and you can make us work as the routing overlay solution, and you can attach all other third-party DNS. We are actually working with partners in that space for a third-party DNS services that we want to provide.
Okay, and then this one is directed toward Danny. DDoS point of view, what does the service provider provide? What does the service provider provide?
So from a service provider perspective, where we're going is, and what we've deployed is, we've deployed a very comprehensive service chain model. And so, we and Viptela is a very critical part of this. And so when you think about how applications are being consumed, we want to be able to serve those applications in a very utility-based model with an overlay of orchestration that creates an automation end-to-end. So not only can you deploy your security services at the edge or consume them at the edge in a virtualized edge solution or through the network, you could also consume optimization services, or routing services, all within a virtualized context. And you can consume them, deploy them where you need them. So if you need security services and DDoS mitigation services, at a certain number of your locations, we can deploy them through the network, within those particular geographies or within those certain locations. And so we've introduced also a different commercial model. So in other words, we're not tying service applications, or licenses to a particular appliance per se, but you can consume them in a variety of different ways. We've got a large catalog, with even micro features to say, okay, you may need, fundamental security images at certain locations and then need to upgrade them at a certain time. You can do that automatically, and you're only going to pay for what you actually use. So in other words, we're going to provide you in a month-to-month kind of a license utility-based commercial model to consume services from that perspective as well.
Great. There's definitely a few more questions coming in. Do you see V-Edge devices altogether replacing the conventional routing infrastructure being provided by other players, Cisco, Juniper, the other larger folks?
So what we have done is we've taken the overlay model and we have simplified the overlay routing functions, but routing has been there for a very long time. If you take underlying infrastructure, you can show up in a data center which is working and has a complete setup of BGP connectivity or a remote site which is running OSPF and BGP. The intelligent routing system should interact with all of them. I mean, people still want to continue on MPLS paths. You can build overlays across it. But within the site, you have your existing routing protocols. So those existing routing protocols should seamlessly interact across this. Replacing BGP to build on the internet infrastructure is no trivial job, and BGP is a very elegant protocol to do the AS path construct and building AS path connectivity. So I don't think it's very easy and it's the right thing to say that routing is gone or you're going to change routing architecture. BGP will continue to thrive, and it's a very elegant protocol for inter-AS connectivity. But your system should be intelligent enough to understand how to interact with these existing routing protocols through the overlay systems.
Great. For handling application-aware routing, path selection management is essential. What's the logic of Viptela's solution-based to be able to enable this? And is it based on a kind of intelligent engine or analytics or some kind of heuristic?
So Viptela right now at this stage has a very intelligent system that looks at loss, latency, jitter of each of those available circuits, and you can, based on the app-aware policies, you can move those applications around. Long term, we are actually looking at introducing our vAnalytics. The analytics will have a much more clear understanding of the circuits, the location, the application profile. In fact, we have some very interesting data for our customers to advise them at what carrier works well with what SaaS providers in what locations. And in what your application profile is, at what point you should consider upgrading your bandwidth because your application profiles have been kept very well. So in a lot of cases, high-profile application traffic take the tighter SLA path in certain cases, and it says if at certain point one transport is behaving better, you can seamlessly move it around without any disruption to your system.
Okay, and I just want to encourage folks to go ahead and download these slides. They're in the attachments and links area, and again, the recording will be sent out to everybody. We're down to a couple more questions, and again, we'll send this recording out to everybody. These are compatible, the last questions here, or last couple questions. These are compatible with all routing protocols. For example, it's BGP peering, and you said that the zero-touch edge is, how does the discovery on the edge? Zero touch. So
when the edge comes up, it goes and, as I'd mentioned, it authenticates itself, and then you have pre-set up templates in your central management system. Then that gets pushed, and then if your local site is running BGP, you have that templatized version of it. It goes and it's configured, and then your BGP peering starts to work. As I mentioned, we can peer across all the other protocols. In fact, as I mentioned, we can detect loops. The system is so intelligent that it knows that if during underlay overlay transition time, when half of your network is running MPLS, the other half is running simple Viptela overlay, and you do want site-to-site connectivity, we have that much intelligence to understand that where the source of this OSPF traffic is, that overlay knows, okay, this route was sourced from data center, it went through underlay MPLS, and it came in on this site. So we will not source that OSPF prefix because we know that the intra-area route exists on a data center while this is an external link state. So we have put a lot of intelligence into the system. That's why our customers, when they see the system, they deploy it and says, that's a very quick deployment because I don't have to worry about all the complexities, traditional routing loops. The system is intelligent enough to work across 3 routing protocols and still interact seamlessly and building it to the overlays.
Great. And our last question coming in here to Khalid, your thoughts on microsegmentation?
Yes, very interesting question. So microsegmentation, I think, is going to happen in the branch. You need it for zone-based connectivity, but it really simplifies your policies because if you look at it, I think of VPNs that we created as segments as macro segments. And in microsegmentation cases, you need, if you look at what happens to policy, your policy is consistent, but identity is not because you're still tying it to IP identity. What if I tie that identity as consistently as well? So you as a network guy can offer a very clear abstraction to your security guys and says, hey, as long as I follow your classification of the identity, if it's an ATM machine throughout my 5,000 branches, they all have the same identity, then my policy is the same, consistent, and so is my identity. Today, the identities are not consistent, so you have to, anytime you provision or decommission any site, you have to have thousands of those ACS provision for each branches because you won't like to permit site-to-site ATM. But with this type of model, Viptela is soon introducing that concept of a zone base, and they'll take that idea into the larger context in our next releases. But again, if you solve problems architecturally correct, you will be able to address so many different use cases that are thrown at you rather than struggling with trying to solve some very basic problems of on-demand control plane connectivity, especially around securities.
Great. And with that, it looks like we've wrapped up on all the questions. If there's any further ones, please feel free to reach out to us, info@viptela.com, as well Verizon. Danny has put his contact information there, Danny at verizon.com, I believe. Danny, is that the correct contact information for reaching out?
Daniel.Johnson@verizonwireless.com, yes.
Oh, my apologies.
No
and then Khalid at Viptela.com.
Yeah,
So I'm sorry there. And we certainly appreciate you joining us today. So that's been a great, very active conversation. Great, and we'll get this out to everybody shortly. Thanks so much, everyone.
Thank you.
Thank you.